Okay, hi, I'm Brian Sosa. This is my recording for how I did the XFLR5 project. So I'm just going to jump straight into it with direct foil design. I'm going to open the Clark Y that I've already prepared ahead of time, and here's the airfoil that we work with throughout the project. So now I can do a direct foil analysis. I'm going to define an analysis here, change the Reynolds number to 1 million. Click OK and analyze. There it is. Yeah, I'm going to show all of the graphs. There they are. Okay, so this is how you generate all of the graphs for the project. If I go to just this one, and then I go to current graph, export, that's how you export all of the graphs. It's just export graph. So it's really, really simple to do that, and this is really the data that's needed for the airfoil itself. Now, I'm not going to leave quite yet because I need to do a batch analysis to get ready for the wings. And so what I did is I used a Reynolds number range between 900,000 and 1,100,000 just to make sure I get that 100,000 Reynolds number. And with the default increment, this is all set up, and so I'm just going to analyze. And this is quick, so there's no need to cut it in post. Oh man. Okay, that's finished. We move to wing and plane design. I'll show this. So I'm going to define a new plane. I'll name it AR4 because that's the first aspect ratio we need to achieve. Take out the elevator, take out the fin, define. Just clicking here will make it all Clark Y. I make the chord length 0.5 meter with no offset. Boom. Okay, so the aspect ratio is 4 and everything is okay. So I can save twice, and there's a wing. Now I'm going to go and define my analysis. I need to change this to 30 meters per second to get that Reynolds number that we need. Save. The alphas are already defined. So there you go. I did my analysis. Unfortunately, it doesn't converge all the time, but I'm not sure how to fix that. Anyways, here, there's graphs for CL, CD, CL alpha, and CL over CD versus alpha. Fairly straightforward. Same process to export. You just export the graph. And I've already done it, so I'm not going to save it on camera. If you go here, you can actually catch the induced angle. And if you go up here to 7 degrees, that is the induced angle at 7 degrees. And if you go to current graph, define graph settings, you can also get the induced drag coefficient, like that, at 7 degrees in particular. So I'll show you how I do this for the other two plane types. Oh, I need AR8. Turn off these two, define. Put in the stuff. What I change is the length to get the aspect ratio of 8 and keep my chord length 0.5 meter. Let's check. It's good. Same deal. Analysis. Keep it at 30 meters per second because the chord length is the same. Analyze. There you go. Adds to the graphs. And if I go to 7 degrees, there's induced drag. And then induced, oh man, induced angle. And now I'll show how I do the aspect ratio of 12. Take out these two. 0, and I change this to 3 for the length, and it gets aspect ratio of 12. Save. Show this again, it's good. So I'm going to define my analysis again, still 30 meters per second, and so you just straight up analyze, and that adds to the graph. So we have all the graphs ready to go, and I just hit 7 here, induced angle, and the induced drag. Cool. So that's it. That's the whole project. So yeah, I'm going to end the video here.